Carla Balo.
Hi, thank you, Sarah. Welcome everyone for joining us. I find this title really quite compelling. AV safety, autonomous vehicle safety, what's new? And it seems like almost we need to have one of these every single day to keep on top of really what's new. Things are progressing, things are getting back on track through COVID. And let me give you a few housekeeping notes at first, and then we'll get right into the presentations by all of the esteemed guests we have with us today. So if we could scroll to the next page, just to remind you, we are recording this webinar, and any presentations that you see that are approved to be shared will be on our website, and the link is shown at the bottom of this page. If you have any questions throughout, we will be monitoring the question portion of the event, and go ahead and submit those in the questions section of your toolbar. We have 3 more webinars upcoming, one within November and 2 in December, all related to Auto Industry X, sometimes familiarly called Auto 4.0 or Industry 4.0. Really talking about a great project we've had ongoing for the last several months with several of our affiliate members. So tune in to listen to those upcoming. We also have opportunities to sponsor any and all of our upcoming webinars. You'll be seeing the full list of 2021 shortly, probably within the next few weeks, and we welcome your sponsorship opportunities for those. And we are doing a lot of work for COVID-19. All of it is unfunded. If you would like to support funding that, it would certainly be appreciated. And lastly, we did CAR MBS 2020 in August. It was all done virtually, but you may go back and take a look at those sessions now. Maybe you didn't have time to watch them then, but they're available now. And if you didn't register, you still can, and you can still see the great content. So with all that being said, I'm going to stop talking for a bit, at least until I start moderating, and introduce the speakers for today. They'll each take time to introduce themselves and give a few thoughts on autonomous vehicle safety, what's new. So I'll start with Greg Brannon from AAA. He is part of the automotive engineering out of AAA National in sunny Florida, I think. So Greg, let's hear your thoughts on the topic.
Thanks, Carla, and I appreciate everybody joining today for a quick discussion on AVs. It's been an interesting year in so many ways. I think particularly on the AV front, there's been a lot of activity and some slowdowns and changes, and it's just a really dynamic environment. So I'm glad we're getting together to talk a little bit about the subject today. For those of you that don't know, AAA, you might recognize as a motor club or an insurance company, but actually at our heart, we are an advocacy organization going all the way back to our roots when we were advocating for equal rights of automobiles alongside horses and buggies back in the early 1900s. And some 120 years later, we're still advocating for motorists. And as part of that work, we have done quite a bit of research around automotive technology, and that's anything from the best type of fuel to use in your car to the latest automated technologies. And so I wanted to take a minute and just quickly talk about our latest findings related to active driving assistance systems. And these are, as defined by SAE, as level 2 systems that you might recognize by names like autopilot or GM Super Cruise system. And so I wanted to mention the work that we've done today, not in detail, and we can happy to answer questions in the Q&A portion, but really the point that I wanted to make is that while there's been a tremendous amount of progress made, and the media continues to enjoy talking about automated technologies, there's a few things that we need to really think about. And the first of which is that these technologies that are available to consumers today are really still in their infancy. And the important point there is that these systems are all driver assistance technologies at this point. And so while the topic here is AVs and using SAE's J3016 that defines the levels of automation, we can put them on a scale of automated technologies, but the truth is they are all just there to assist drivers today, whether in safety or reducing workload while driving. So our recent research, which we conducted out in California, both in naturalistic settings on the highway, as well as closed course evaluations of data loggers and all that type of equipment, what we found is that in the naturalistic setting, which is where it's best to evaluate these type of systems, these driver aids, is that we had some type of issue once every 8 miles that caused the driver to have to correct for something the automated system did not see or do or did improperly. That's once every 8 miles, and so that's a significant amount of control and direction that these systems still need. And it's an important point, and I'll just underline it again here, is that these systems are not meant yet to be a replacement for a driver, but rather an aid to a driver. And it's interesting, we really have been keeping tabs on consumers' perceptions of more automated technologies as well over the past few years. And our recent surveys showed that only 12% of US drivers would feel comfortable or safe riding in a fully automated car at this point. And we've looked at that stat for several years, and we have not seen a tremendous amount of change, despite the amount of media and attention that's put on the technology. I think one of the main reasons there is that drivers have not had a chance to experience it themselves. And so one way that they're going to experience it themselves is perhaps through these levels of automation, right? Going back to our active driving assistance work, where the first exposure someone may have to an automated technology could be something like lane keeping assistance or adaptive cruise control. And unfortunately, in the cases of those technologies, they're going to find that there's really a lot of room for improvement. So our concern is that over time, that consumers may get a more negative impression on the technologies as they're rolled out in these driver assistance technologies, unless they're done really well. And so that's an important point. And the other thing to remember here is that we have to, with these automated technologies, bring the drivers and the consumers along for the ride. And a recent study showed us that 40% of Americans believe that systems with names like autopilot or ProPilot or Pilot Assist have the ability to drive the car itself. And we all know, I suspect everyone on this call knows that's not the case, but 40% of Americans believe it to be the case. And so that's why we feel that it's so important to deploy these technologies safely, to do it in a way that has naming that is clear and concise and will allow people to understand the purpose of the technology, and to do it in a methodical, slow manner, just as we deploy other technologies in the automobile. So I'll stop there and look forward to the Q&A portion.
Greg, thanks. Just one quick question as you were talking. Is AAA involved in some of the nomenclature issues that we're facing today with this plethora of names, even in the ADAS systems?
Yes, absolutely. We actually led an effort that started almost 2 years ago now to call for industry standardization of ADAS system nomenclature, and we're very fortunate to be partnered in that effort with Consumer Reports and IIHS, or rather JD Power, and National Safety Council, and more recently DOT, NHTSA, and SAE. So we're getting some really good momentum there, and we believe there's a lot of work to go, because again, we feel that it's important that these systems are identified in a way that consumers can understand what the design intention and how to use the system safely.
Thanks. We're going to come back to a number of the points that you just talked about. Our second presenter today and participant is Leslie Newtboom, and I'm certain I just killed that last name, but welcome, from Humanizing Autonomy. He's the co-founder and chief product officer there. So Leslie, your opening remarks, please.
Yes, thank you, Carla. So Humanizing Autonomy, I'll give a brief introduction to the company. We're a predictive AI company that is creating the global standard to how people and machines interact. Simply said, we build computer vision software that predicts pedestrian behavior and vulnerable road user behavior. So that allows human-driven vehicles to warn the driver when there's a risky situation, and it allows autonomous vehicles to drive more safely, more efficient, and also offer a smoother ride to the passengers of those vehicles. So there's a range of applications that our software plugs into. So we have production licenses in technologies like forward collision warning, blind spot monitoring, and path planning for autonomous vehicles to both determine whether the vehicle should slow down, brake around vulnerable road users, or continue driving to be passed to a risky vulnerable road user. And to kind of touch upon what Greg said, not only is there a lack of trust in people who are driving inside vehicles that have automated systems, but there's also a lack of trust of automated vehicles for the people around those vehicles. So this is what we found when we were doing research in London, which is that practically no one would trust an autonomous vehicle to take into account their needs to understand their behavior for the car to be safe for them to be around. And we thought that was quite a shocking finding, and it led us to look into how these vehicles did understand people. And we found out that they didn't. They had distances to people, and they knew that it was a person, but that's about where it ended. And even those systems didn't perform as well as they should have. This was also proven in the AAA research about automated emergency braking around pedestrians. And I thought that was a shocking outcome, to be honest. I was definitely hoping for those systems to perform better, but they didn't. And that's exactly the problem that we're trying to solve. So the way we're doing it is we're building interpretable AI. So rather than this black box AI solution that doesn't allow you to understand what it's basing its decision on, it uses a modular method that allows you to understand this AI made the decision to brake because it predicted the person to go in that direction because of these, and these inputs, while preserving their privacy. And I think that's an essential part of these technologies as well, to continue having the trust of the people around these vehicles, not only in their safety, but also in the protection of their privacy. So we actually tested that software on similar operational design domains as were used in the AAA research, but we did it on real world data because we had access of, for example, dash cam footage or camera footage from vehicles that were driving through these cities and being involved in actual accidents. We were able to then compare what our system would have done in that situation rather than how the driver behaved. And it was even surprising to ourselves that in some of these cases, we responded more than 2 seconds earlier than the driver responded to an accident. And we had less false positives than the physics-based models because we added an understanding of human behavior rather than just the movement of the person. So we also discovered that to have our software in an autonomous vehicle is going to be a long way out for many of those vehicles to drive around our cities. So we focused on ADAS early. But even ADAS is a very lengthy integration period for a startup. I mean, 3 years is quite a long way out for a startup to get funding, to prove the application of the technology, and then to be able to generate revenue. So we started focusing on even lower power chips than are used in ADAS systems, so that we didn't have to deal with the traditional automotive timelines. And that meant that we were able to put that software on mobile chips, such as in your smartphone, such as in dash cams. And I think that's actually a really interesting topic that I'd love to discuss in this talk, where I was wondering, how does AAA think about these types of devices and how to test their impact on the safety of a vehicle? And the same way with Kevin, who's coming up, is how do you make sure that these computer vision models can run on the edge when your chip pipeline might not be entirely clear yet? And when you don't really know which chips are going to be available in 3 years, because it develops so quickly, where you'll have much more processing power available for the computer vision models that you're deploying right now for cars that will come out in multiple years later. So I'm very excited about this chat. I think we touch on very different aspects of the problem of safety, but for now I'll give the word to Kevin.
Well, thank you, Leslie. And if I don't remember your question that you just posed, remind me, interrupt me later, because I think that is a good discussion amongst the three of you. The third presenter today is Kevin Mull. He is Mobility Solutions Sales at Bosch. And I know we're going to hear a lot about, you know, the parking garage project that he's doing in downtown Detroit. And maybe we'll hear about a few other things. So Kevin, go ahead and take the floor.
Yeah, thank you, Carla. Hi, everyone. This is Kevin Mull, as she said, longtime Bosch guy. And I'm probably going to pivot the discussion here just a bit into a mobility use case that we think is something that's really high value for vehicle drivers, and it's around parking. A lot of people say that, you know, everyone loves to drive, but nobody loves to park. And I think that's a relatively true statement. So what we've done is develop some technology that we call AVP, or Automated Valet Parking Technology. We recently did a demonstration project here in downtown Detroit, and I'd like to take you through that. So I need to share my screen here. There we go. 1 second, folks. It should be coming up.
We can see it, Kevin.
Great, thank you. So I'm not sure exactly who's on the call, if anybody on the call had an opportunity to visit us for this demonstration or participate in some of the events that we did around it, but what we did is we created a real-world parking experience in downtown Detroit via a really special and unique partnership with Ford Motor Company and Bedrock Detroit. And this project really was originally designed to complement the North American International Auto Show, which was to have occurred in June of this year. Everybody knows due to the pandemic, the auto show got canceled, but we were able to develop a new timeline with our partners and deploy this demonstration in spite of the pandemic, and you know, we're all very happy with that. So what we did is we upfitted a garage, a brand new garage that Bedrock has built in the Corktown neighborhood of Detroit, called the Assembly Garage. And we worked with Ford Motor Company to enable 2 production Ford Escape vehicles. And these 2 vehicles were purchased from a dealership lot, so they were production vehicles. And we put on a real world automated valet parking demonstration in the Bedrock garage, and it included several parking maneuvers, a couple of safety engagements, including with other vehicles and pedestrians. And we're really able to demonstrate to people how this technology could work. And I'm going to share some of the feedback with you in the next couple of slides. So the first thing, just to set the stage on what is this technology. So this is an infrastructure-based technology that uses sensors in the parking environment to detect, to localize the vehicle, do its path planning, and basically command the vehicle from the drop zone to the parking spot, and then through other maneuvers. And we think that, you know, all the stakeholders in this parking ecosystem benefit from this technology. Is, of course, the consumer, you know, is able to benefit from a truly automated valet experience. I think everybody understands how a valet, traditional valet parking experience works. Well, we've automated that through this. For the OEM, it allows them to deploy a capability on the vehicle that's attractive to the consumer, that is, you know, additive to the emerging ADAS functions that are coming on the vehicle. And then for the real estate developer, this really allows them to leverage some mobility technology to better optimize the use of their asset, to do things like increase density. We think that there's a 20% density improvement. It's just simply by the fact that you can park the cars close enough together that you don't have to open the doors. But more importantly, especially for somebody like Bedrock, it creates an experience to attract people to their properties and differentiate them from others in this space. So, you know, we were able to prove through this demonstration what these stakeholder benefits were. Now, a little bit about the technology, and this is a really important part of the discussion, maybe a little bit different from, you know, Greg and Leslie's previous points, in that I mentioned earlier that we leveraged a production vehicle, and in order to create this capability, you simply need some base, you know, systems on the vehicle that many vehicles already have today, which is, you know, shift by wire, steer by wire, brake by wire, automatic electric parking brake, remote start and stop of the engine, and then in our case, V2I, vehicle to infrastructure communication via Wi-Fi. So if the vehicle already has that, then it is eligible for this AVP solution. So in our technology, we're not using any of the vehicle's sensing or compute capability. We are doing all of that in the back end, and that comes through the infrastructure. So as I mentioned, we used Wi-Fi, so this was just through a standard access point. We used in the demonstration, we used LiDAR as our sensing capability, but we're moving towards stereo cameras, and I'll talk a little bit more about that later. And then we're using a garage server to do all of the calculations and provide the instruction and the communication to the vehicle. And that's what manages that experience. So here you can see a photo of the vehicle in the Bedrock parking garage environment. You see the LiDAR on the floor surface. We created an array of LiDAR that was able to monitor the vehicle movement. And one of the topics that has come up is, you know, how does a pedestrian engage with the vehicle? Well, the LiDAR is able to sense the pedestrian in any proximity to the vehicle, and if the vehicle senses a pedestrian near it or in its path, it will automatically stop the vehicle. And we had several demonstrations of object in path that even the vehicle engineers that came to the demonstration acknowledged that the vehicle sensors would not have been able to stop the vehicle in that particular condition that we demonstrated. So the LiDAR array is really effective in monitoring what's happening in the environment. So as we rolled this out in August, we had several key steps. I just want to use this to set the stage about a little bit of the interest in the market around these types of technologies. So of course, we got our executives up to speed on what we were doing in the first event. Then the media event, we invited reporters to the garage to experience it in person, always, you know, working towards COVID guidelines. We got a lot of attention in the media. You can see here 221 stories posted with a reach of almost 1 billion people had access to that information, including social media. Then we did an industry event where we had a lot of OEMs and industry stakeholders join. That was a virtual event. And then finally, we ran live demos for about 5 weeks, and we were able, even in the time of the pandemic here, we were able to conduct 45 in-person demonstrations with about 120 people, and it's some really good survey feedback, which I'm gonna share with you. So the first thing that I want to point out here is, you know, we got really good scores, which of course we were very excited about. But this was not like an easy crowd. 78% of the people that saw the demo had actually seen a driverless vehicle before in person. So, you know, this was not like a gee whiz effect. It was people who have seen this type of technology before. 100% of them stated that this technology met or exceeded their expectations. So we were really pleased with that. And then on a scale of 1 to 5, 90% of the participants scored this greater than 4 in its ability to manage the parking experience. So there was a very high comfort level with the safety of the vehicle operation in this, admittedly controlled environment. And from a business model or commercialization standpoint, 78% said that they would also be willing to pay for this vehicle features. So that gave us an indication that there is a demand for this capability in the market. So a couple of key takeaways, and maybe this can prompt some dialogue as well. Because this is an infrastructure-based solution and it's not dependent on the full sensing and compute of the vehicle, and it's in a parking structure, which is a very controlled environment, we think that this type of a driverless solution can get into market perhaps faster than the path that others are taking, at least for this particular mobility use case. Also, even with a fully autonomous vehicle, there is going to need to be input from the infrastructure. The vehicle still needs to know where available parking space is, and it needs to know how to get there. So even down the road with fully autonomous vehicles, we think there is a need for this type of technology. Scaling, probably very obvious, but industry standards are going to be critical, especially when you need to apply technology to the vehicle and to the infrastructure. So we need both sides of that lifting at the same rate. From a regulation standpoint, there was a ton of interest as we reached out to the local, the state, the federal regulatory authorities about what we were doing, and everybody was very interested. But there was, what I would call a low jurisdictional interest, meaning, most acknowledged that the configuration of the system with the vehicle not making the decisions itself, there was a lot less interest in trying to be involved in how that technology was rolled out from the regulatory authorities, which also makes us think that it could be a little bit faster path to market. Of course, being able to demonstrate the technology in a real world environment, that's why the partnership with Bedrock was so important for both Ford and Bosch, because we were deploying this in a real parking garage with a real parking operator and able to get that kind of feedback, just as one example. The ROI I already talked about, and then last but not least, I mentioned we're moving from LiDAR on the ground to a Bosch stereo camera based solution, which will go move the sensing up into the overhead of the garage, get it up off the ground. And we think that this is very compelling because it can still do standard security camera use cases, but it gets it out of the way. It's lower cost, and with edge computing, we think we'll be able to have an even more robust compute strategy with the cameras. And finally, just to close that out related to the cameras, after we did the Detroit demo, we rolled out the same technology in Germany at the Stuttgart airport in partnership with Mercedes-Benz. So the Mercedes-Benz S-Class that they just released has this as a series production capability, and as parking garages become enabled with this technology, drivers of the S-Class will be able to leverage that. And we've also engaged APCO, which is a big parking operator, again, to try to accelerate the deployment across their portfolio as well. Lastly, there's a bunch of video out there on these projects. If you were interested in looking at them after this session, we'll make sure that you get those links. So that's what I wanted to introduce everybody. Thank you so much for the time on that, and I look forward to the open discussion.
Thank you, Kevin. Great presentation. Can I just ask one question about the vehicles themselves? It can't be any vehicle. It has to be one that has V2I capability. That's why you updated the escapes?
Yeah, that's correct. It needs to have those base functions. So it has to have the ability to communicate with the infrastructure. And our deployment It's just standard Wi-Fi that's enabling that. And then the vehicle has to have those base functions, you know, the drive-by-wire, steer-by-wire, brake-by-wire, etc.
Thank you. Okay. So I have a follow-up, but I won't ask it now. It's relative to human behavior and the parking situation and consumer trust. But I'll come back to that one as we go through. So Greg, I wanted to come back to you first. And you mentioned in your intro that when you were testing some of these systems, you had an issue every 8 miles. And wow, those of us in the business think that's pretty darn frequent. And you know, did you see certain things over and over again? Did you see any trends? And what do you think is, you know, behind some of these shortcomings that you're seeing? And what other insights might you have gleaned?
Yeah, so really thinking about the active driving assistance or the L2 technologies that are out there today. We've tested these systems over the past 3 years, different generations of the systems, and have found that really the Achilles heel here for those systems is the lane keeping ability. And no surprise, really, because adaptive cruise control has been on the market for, you know, well over a decade, maybe approaching 2, and the radar and camera technologies that support that work pretty well. But lane keeping is really a challenge for these systems, and that has to do with I think just the reality of a few things. One is the roadways in the U.S. and probably everywhere in the world. There are very few roadways that have perfect lane markings and that the cameras are able to see and interpret those markings perfectly all the time. So they're challenged. They're challenged by things like entrance ramps and mild curves and construction areas and worn pavement and those kind of things. Just like humans are challenged in those situations, but we are able through all of our other senses to create kind of a more accurate depiction of the environment. And I think the biggest challenge for these automated systems today is the over-reliance on camera. And the fact that cameras don't work really well at night. They don't work well in inclement weather. They don't work well in glare situations, and because they all rely on contrast, right? Cameras work on contrast, and just like our eyes. And whenever that contrast doesn't exist, the cameras cannot interpret what's going on. And that's really the shortcoming that's out there today, and why we believe that, you know, sensor fusion is really the path forward here. And I think what Kevin was talking about with LiDAR and some of the aspects that Leslie is bringing up, I think that, you know, we have a path forward for this, but it's not a quick one, and it's going to take some more work on sensor fusion. It's our belief.
Thanks, Greg. So Leslie, I'm curious, you know, when we're talking about the car being unable to interpret some of the things we can as drivers. I mean, I think about when there's no lane markings, when I'm on a newly paved road, well, heck, I know about how much room I have, right? And depending which lane I'm in, or if, you know, there's no lane marking and an exit ramp, I can see the exit ramp. So how does your software help with some of these issues Greg is describing?
Yeah, for sure. I mean, it's different in different cultures as well. So some people will take into account the curb much more than in Tokyo, for example, than they would in Mumbai. So even knowing as a vehicle where the lane is isn't enough, because people will also treat that lane differently in different places. So that's where the whole interpretability of the model comes in again, because that allows you to also tweak how that model responds to different people. Because if you would build this end-to-end system that understands human behavior throughout the whole world in any environment, you're just going to have to get a massive amount of data for each new place where you want to put a system like that in. Whereas if you've got a modular system that says, okay, take as an input the environment and where the lanes are, take as an input the pedestrian, where that pedestrian is, take as an input where the pedestrian is looking, then even just with 3 of those simple inputs, you can already tweak it for different cultures and different behaviors worldwide. So I would say it's even more challenging than just understanding the environment. It's also understanding how people act differently within those environments.
So I have to ask then, as an automaker, and then Kevin, I'm going to ask you a question on the same topic, but Leslie, as an automaker, if my car is being sold in Europe, let's say, and that means I have no control if it's going to be in Spain or Italy or Germany, and there's much different driving patterns there. Is there going to be a way that the car knows when it crosses the country border it needs to think differently, or how is this going to work?
It probably already does. You have GPS in your car, so you will know where you are at which moment in time. What Kevin brought up was also very interesting, which is that the infrastructure understands a lot about what's happening within it as well. So we've also been involved in several projects where the infrastructure informs the car about stuff that the car can't see yet, or that the car can't see properly. And I think that's another crucial part in very complex situations, like around schools, for example, or where you've got very narrow corners where the car's view is occluded by buildings or traffic signs. It will be essential for that car to get input from other places that might have a better view about what's going on. So additional to uploading a new cultural behavior of different environments, you should also make the environment as smart as possible and maybe a bit more structured. To Greg's point, I think the Netherlands is actually one of the best places in Europe to deploy autonomous cars. And that's mostly because the lane markings are so accurate and so clean. So if that's a way to accelerate the whole process, maybe there should just be a lot more investment in infrastructure rather than research in these vehicles.
That's a very interesting point. Kevin, I think you can, chime in here on the infrastructure side. I was real curious when you were talking about Wi-Fi and talking about the sensors in the garages. These garages are old. Most of them are thick concrete. How are you managing the infrastructure in each different level? And, can most of these folks that own these garages, can they retrofit even properly to be able to have these kinds of systems?
Yeah, it's a great question. And, for sure, similar to what Leslie was saying, every garage is also going to have its own culture, so to speak, in that, they're all built a little bit differently. And, you've got current existing build space versus new construction and so forth. But fortunately, in our particular case, this automated valet parking technology is really a relatively easy retrofit solution. So installing, the necessary amount of LiDAR or cameras to fit that specific structure, being able to just, amp up the wireless infrastructure with access points and so forth. We're pretty confident that those will not be barriers for us. I don't want to trivialize it. It's not easy by any means, but those are not, real barriers for us. And I think, it's depending on the right application of technology. So, similar to what Greg was saying, cameras are not great for everything. But if you're in a controlled environment where you've got consistent lighting, for example, and you can really control the line markings and things like that, we believe that cameras are going to do very well in a garage space. And in fact, one of the benefits of the cameras over the LiDAR is that, if it's LiDAR, there's maybe something in the path of the vehicle, but you don't know what it is. If it's, cameras that can do object classification, we might know that's a piece of paper, go ahead and drive over it, or no, there's a nail laying there, somebody needs to go pick that up. So we think that there will be some benefits that are coming with the cameras to help better inform the garage in that environment. And as Leslie said, in a multi-level garage, the vehicle can only see what's in front of it. If it's going up a ramp, it doesn't necessarily know what's at the top of the ramp. If it's going around the corner, it doesn't necessarily know what's around the corner. So that's where sensors in the infrastructure can create a nice offset for that by being able to, give information to the vehicle that it can't get with its own sensing capability.
So let me ask you, when people drop their vehicle off, or in your trials now, are people sitting in their car to see what happens, or are they hopping out and you're running these without any people in them?
Yeah, there were a couple of dynamics at play there. First of all, both Ford and Bosch, and of course with Bedrock, we established our safety protocol, and we were able to operate the demonstration without any person in the vehicle. We had a remote stop switch that we could interact the vehicle to stop it if needed. If somebody wanted to be in the vehicle during the demonstration, we could do that only with a safety driver in the car. That was the protocol that we developed. Okay. Due to COVID, we would only allow one person in the vehicle with the safety driver. But it was one of the things that was most impactful, I think, about the demonstration was, what we did is we simulated a person coming in from the street, through the gate, into the drop zone. She got out of the vehicle, initiated the parking process with the app, and the vehicle literally drove away. She walked away out of the garage in most cases, and you could see that vehicle was completely operating independent of the driver. A different kind of application of a driverless vehicle technology, but I would argue that at the end of the day, the consumer is not going to care whether the vehicle is doing the sensing and making its decision or it's the infrastructure. They just want the car to go park. So they're not really going to care, where the sensing and decision making is happening.
So Leslie, let me go back to you about, ADAS and automated technologies and intermingling that with human behavior and human machine interface. Are there things that automakers in the industry can do better than they are today to get the customers more ready for this upcoming technology? Is there something, as they go from let's call it a legacy vehicle into a car that's equipped with at least some factions of ADAS, is there something that we should be doing differently to help them understand better, or will technology just take this learning away?
I think there are definitely things that can be done better. Maybe actually one thing back to what Kevin was saying. I feel like, yes, you could take sensing to the infrastructure, but you need to have a common understanding between the vehicles and the infrastructure of what it's seeing. So you actually have an IEEE standard for infrastructure-based cameras and how you determine the subjects that you can see within that camera and how they're moving around. But they're not matched at all with the automotive standards. And I think that's a massive challenge, because if you are defining someone's human behavior, for example, differently from an infrastructure camera than the vehicle would assess that behavior, then there's huge confusion between how to react to such a person when you see them from both angles, for example, or you might react to it differently based on your infrastructure information rather than your vehicle information. So I just wanted to mention that. Sorry, Carla.
That's all right.
But one of the things that I think Waymo and Tesla are actually doing really well is informing passengers of the vehicles about what the vehicle is seeing and why it's making its decisions. So I think you can just keep the car from the inside a black box as well. So if a person has no idea why a vehicle is swerving, why it's braking, why it might be driving more slowly, you'll get agitated people. And if you've got a person sitting in that vehicle that is seeing a child run across the street, but doesn't have any idea whether the vehicle understands that that child is there or will be in front of the vehicle, then that person is going to be much more likely to press the brake as soon as they can. So I think you'll need to give more kind of trust to people owning these vehicles that the vehicle is doing a proper job. And I think that the screen in the dashboard is a great way. Maybe you can use auditive signals. I don't know yet, but there's a lot of interesting design challenges there.
Greg or Kevin, do you want to react to, what we could be doing better? Or, maybe Bosch is already thinking about this with the parking solutions, or, what are you hearing from your constituents, Greg?
I think one thing that we could be doing better is, Leslie mentioned it earlier, we've done some research with automatic emergency braking systems related to their ability to identify and react to pedestrians. And I think that's a clear example where the industry is kind of missing the boat. The vast majority, 80% of the pedestrian deaths that we have, some 6,000 a year, happen at night. And these systems don't work at night at all. And the current test standards don't call for them to be tested at night. And they don't call for them to be tested at speeds at which that people would actually die. So we're talking about testing a pedestrian detection system at 12 miles an hour during the daylight. I would argue there's not very many pedestrian deaths that happen at 12 miles an hour during the daylight. And so I think as we think about what the industry could do to really do better in this space, is to look to find the situations where we can have the greatest impact. If we're really serious about adding the ability for the car to detect and respond to pedestrians, we should do that in the context of when people are actually dying on the roads. And that's going to take some technology that's been out there for years. Thermal imaging is not a new thing. And that type of technology is what's going to maybe combined with LiDAR. That is the type of technology that's going to be necessary to make that happen. It's out there. We're just going to need some regulation and some momentum for the industry to correct it. And that's just one example. There's many, if you look across the spectrum of these technologies that fall into the same category. I think in many cases vehicles are being designed to pass the tests that are out there as opposed to solve the actual problem.
That's an interesting point, because being normally in Michigan, I'm not at the moment, but normally there, and deer season is starting soon. One of the things that we see all the time is the collisions with deer, and that's normally at dusk and dawn and at high speed typically. So there's nothing you can do. So I wonder if we should start our testing there, with the deer population, and then bring it into the human zone. But Kevin, in your parking garage, there's so many people walking around, I'm assuming, and we don't always know they're there. We're not going to disallow them to walk around. How is your system thinking about this night vision and or managing pedestrians? Or, I'm sure you'll have other ground lots and other examples later.
Yeah, good question. I was going to comment on what Leslie was saying, and also Greg. First of all, I completely agree. Standards are going to be crucial, especially as somebody like Bosch is trying, in simultaneously in 2 dimensions to create systems that work across multiple OEMs, but now bring in, who knows how many exponential factor of infrastructure providers that are trying to deploy technology. So no doubt standards are going to be absolutely critical. In regards to the pedestrian use case, I'll spin it around and take it the other way. In our demonstrations, we were able to show that as a pedestrian entered the path of the vehicle, which often happens in a parking garage, the vehicle, of course, slowed and stopped because the LiDAR was sensing that person in the infrastructure. But as the pedestrian, how do you know that the vehicle sees you? And as the pedestrian walked away, the vehicle would start moving again, and when they stopped, the car would stop. And it's this interaction. What kind of indication do you get from the vehicle that tells you that vehicle sees me? Or if I'm in the garage and a car is doing a driverless maneuver and I'm in my car behind it and I'm getting frustrated because it's moving slowly or whatever, how do I know that that vehicle is in that mode? One of the opportunities that you have in a parking environment that you can leverage there is you can create a space where it's automated valet parking only, where the driverless vehicles are operating in a secure space where there is no other driver-based vehicles. There are no pedestrians in that space, and allows you to deploy the capability as you learn more about how those interactions go. So, we think that's another advantage to working in this domain that will benefit, fully autonomous vehicles down the road, because there are learnings here that can be applied in other areas. But it's starting in a much more controlled environment where you can really limit the number of variables that you have to deal with.
Thanks, Kevin. want to talk a little bit about ADAS systems and driver assistance and driver engagement. And then maybe we talk a little bit about level 3 and if that's even possible, and then moving into level 4. Greg, you were mentioning how many false positives exist. I've read literature that false positives causes many people to just turn off the systems because they're annoying them. So the things we're putting on the product to keep them safe are not keeping them safe. And then, you know, the actual understanding of those systems, or, you know, the feedback probably isn't existing either. So, you know, what about driver assistance versus driver engagement? Can we ever really expect the driver to stay engaged long enough to manage to, you know, take control back, as we're asking in level 3? You know, where do we go kind of from here with the lessons that we've learned so far with level 2?
Yeah, it's a really interesting. I think we're going to do a whole webinar on this one topic. Honestly, it's a very challenging situation. I do not envy the engineers at the automakers that are trying to balance these things. Just from the start, if we're talking about a level 2 system, and as we head into level 3, there is a balance between system efficacy and driver engagement, right? So we already see some disengagement today with the systems that are failing or having some type of issue once every 8 miles. What happens whenever that gets better? And that goes to once every 20 miles or once every 50 miles. How engaged is the driver actually going to be in the task of driving if you're not asking them to do anything except maybe once per hour on a road trip? Not very engaged. So it really is a challenging concern for the engineers that are tasked to develop these systems in a safe way that have to take into account the human machine interface and the safe operation of the system. We believe that the better that the level 2 systems, these active driving assistance systems, get, the better the driver monitoring is going to have to be to ensure that people stay connected. As far as level 3 goes, it is going to be challenging. I think we have seen many automakers, particularly some German automakers, that for years have promised, oh, next year we're going to be deploying a level 3 system, and we have not seen that deployment yet. My only guess is that the lawyers get involved in that decision, and the regulatory bodies get involved in that decision, and somebody points out that it's probably a really bad idea to take somebody that is not engaged in the task of driving whatsoever, reading a book, taking a nap, even if it's just in limited scenarios, in limited domains like on a highway. Our research has shown that it takes someone, even from a conversation on the phone, it takes them up to 20 seconds to re-engage fully cognitively in the task of driving. So if you go from reading a book or bouncing your checkbook to doing an evasive steering maneuver, the chances of being able to pick that up and do that quickly are very, very thin. So that puts the burden on the automaker to have the system be able to see some 20, 30, 40 seconds out on the horizon. If they could do that, they would just make a fully automated driving system.
Greg, do you have any data by chance on the Cadillac Cruise system that, does detect and, will pull itself over if the customer's not engaged?
We do, and in fact, Super Cruise was included in our latest evaluation, and in fact, it had about half as many issues on the open highway as did the other systems. However, the system will, even whenever it believes that you're on a piece of LiDAR mapped interstate that the system should be mapped for, the system will occasionally, and we found this often, over the course of thousands of miles of driving, is that the system would turn it back to you very quickly, and oftentimes in situations around curves or in areas where if the driver's just kind of staring blankly out the windshield, they're going to be pretty surprised when that steering wheel flashes and it says back to you. Now, we understand that Cadillac has built some safety controls into that system, and that the handback may seem severe, but it's probably more gradual than appears to the consumer. But it's quite alarming if you believe the car is driving and and you're counting on that and maybe daydreaming a bit, and all of a sudden find yourself in a automatic emergency braking situation.
Leslie, I want to go back to you for a moment and talk about the human behavior and the interpretation, and really making the car think more like a human, or being able to interpret. What role does simulation versus on the road or contained testing play in all of this? And is it your vision that a lot of this can be done by simulation in the future, and or do we need to do a lot more on the road work?
I believe that simulation is really only relevant for extreme edge cases where you don't have any real world data. When you have real world data, it's always going to perform better than if you've trained something on a simulation, because it won't get hung up on graphical weird artifacts that are maybe in your simulation. The simulations are also not as complex as human behavior yet. So you'll see someone running, you'll see someone turning their head, but you don't have the intricacies that you have in the real world in your simulation. So that's why we've held off for simulation-based training up until now. We've only used real-world data to train our models. It's likely that we will need to use simulations for some extremely edge case scenarios, but preferably not. I actually like I like that you asked this, because I think that data sharing is one of the core things that we need to do to make these systems safer. Let's say you have an entire fleet of vehicles that are driving through a city. If you have access to the data from all those vehicles' cameras, you can actually create hotspots of where certain risky areas are. We have this backend to our software for the fleets that we deploy in, but it's only a limited amount of vehicles. It will give you some location-based information. So these streets often have higher risks of these vehicles around these pedestrians. So you'll also be able to like highlight certain geo-based like hotspots of risky areas around schools, for example. But unless you have access to many, many more vehicles than just, let's say, the London buses, you won't actually capture the entire city. And this is one question that I had for Greg and Kevin, which is, how do you see data sharing as being a method to also benchmark the performance between the different suppliers of safety systems? And rather than having to simulate a scenario with a doll that doesn't look like a proper human if you look at it from a camera, for us at least, for a distance-based sensor it might, but how do you foresee a system where you can actually use real-world accident data or near-miss data to then compare how different suppliers? I know data is the next oil.
Yeah, I think that's a great question fundamentally. Everyone's getting data, everyone's keeping data. It's not being shared today, and I think it's going to be really, really interesting when we have all these different automakers and startups put their products on the roadways and then see what happens. But hopefully we'll do things much smarter than that. Unfortunately, we don't have time to address that now. I've only got 2 minutes, so I'm going to do a quick round robin and just ask you, what do you think will be the main industry experiences or automotive experiences and changes that we're going to see over the next, let's just say 3 years. I think 5 years is too far out. But, what are those 3 things that the industry will see and experience, over the next 3 years, let's say? And I'm going to start with Kevin, go to Leslie, and end with Greg. 1 minute. No, 45 seconds max.
I'll probably be briefer than that because I think that's extremely difficult to predict. I do think, though, that we will see a lot more real-world demonstrations than we've seen so far. I think that the confidence in the technology is growing enough that we're going to start to see more people putting their tech out on the road, so to speak. I think that we'll probably see some, more companies go away and some new ones come in. And also, I think that, and this maybe is a little bit of an acknowledgement to Leslie's question a moment ago, is I think you're going to see some more, really unique partnerships, and partnerships that maybe at face value don't seem to make sense, but in the end will make a lot of sense. I think those are the three things that I would anticipate.
Thanks, Leslie.
I'm a bit sad to bring this one up because it's not a positive one, but I think we'll see a lot more accidents between automated systems and people. And what I hope for is that there will be some sharing of insights and sharing of data for everyone to learn from those, rather than keep it to yourself.
Great points. And Greg, your final thoughts.
Yeah, I think like the rest of us, the automotive industry and the tech companies that are working in the automated space are going to be still reeling from the implications of COVID over the next year, maybe longer. Funding is going to continue to be a challenge. So I think we're going to see, I've been saying for a while, and I really believe that it's the case, that the automated technologies is going to be an evolution, not a revolution.
Great closing comments. Thank you, Greg, Kevin, Leslie, for your time today, your great input to this topic. And I think we're going to have one of these much more frequently because things are just changing so fast. So again, for those of you who joined us, this has been recorded. You'll be able to watch it again, share it with your colleagues. Have a great rest of your day wherever you are. Thank you.
Bye.